This course module will familiarize you with the applications and application areas of the pressure transmitters. In the energy market, one important measurement is flow of flue gas. The challenge is the very low differential pressure ranges needed, down to 0.05 kilopascals, which can easily be realized with the available differential pressure cells. Also, the pressure in general is low, about 0.2 kilopascals. Pressure cells with capacitive sensors are available which allow an overload up to 1 megapascal even with these small ranges. Due to the chemical composition of the gas, high corrosion-resistant diaphragm material is often necessary, which can be provided as Hastelloy C for differential pressure and ceramic for pressure measurement. At the combustion chamber, the flow and pressure of both the fuel and combustion air have to be measured, again with low ranges as before, down to 0.05 kilopascal for differential pressure and 0.2 kilopascal for pressure measurement. For flow measurement, differential pressure transmitters offer an adjustable low-flow cutoff function, so that you can be sure that in the case of no flow, the transmitter output is really zero. Pressure and flow measurement in the feed water and steam system of a plant require both pressure and differential pressure transmitters with a working pressure up to 41 megapascals. Flow measurement in these systems is mainly achieved using a primary element and a square routing differential pressure transmitter. Due to the high temperature of the measured medium, steam or very hot water, DP flow measurement is often the only way to measure the flow. For temperature and pressure compensated mass flow, multivariable transmitters are used. At the condenser, level and pressure measurement is carried out. Both applications are running under vacuum conditions. The most simple connection of the transmitter to the condenser seems to be via impulse lines. But because of the vacuum conditions, you'll get fluctuating condensate levels within the impulse lines. That prevents the transmitter from providing stable and accurate measurement. The solution for this problem is a transmitter with diaphragm seals instead of impulse lines. Due to the all-welded technology, the diaphragm seals fit perfectly to this application and avoid the problems of transmitter connections with water-filled impulse lines, so-called wet legs. The oil and gas offshore applications for pressure transmitters are in pressure and interface level measurement at separators and level and pressure measurement in the firefighting system. Interface level measurement mainly uses low differential pressure ranges depending on the difference in density of the two measured media. The preferred connection method for differential pressure transmitters is via diaphragm seals. These are easy to install and avoid problems which could be caused by liquid-filled impulse lines, called wet legs. For example, bubbles in the filling of these lines, etc. Due to the measured media, the parts in contact with the medium need high corrosion resistance. The firefighting system operates with seawater, which requires seawater-resistant material for the diaphragms, for example, super duplex or Inconel. The distillation process of crude oil requires measurements of top pressure at the upper end of the columns at process temperature up to 375 degrees Celsius or 707 degrees Fahrenheit. It requires additional level and interface level measurement under vacuum conditions on the one hand and at high temperature on the other hand. For these requirements, ABB pressure and differential pressure transmitters with diaphragm seals are the perfect solution to provide accurate measurement with high stability. The onshore oil and gas industry uses pressure transmitters for level measurement in tanks. Because the tanks are open to the atmosphere, they are not pressurized, so for measurement, gauge pressure transmitters can be used. Very often, transmitters with diaphragm seals are used. As well as their ease of installation, an advantage of diaphragm seals is the big choice of corrosion-resistant materials for the wetted parts. The sometimes very high process temperatures require remote diaphragm seals with capillary, which are suitable for temperatures at the seal of more than the 350 degrees Celsius requested in these applications. To protect the environment from the liquids used in this industry, an overfill protection for these kind of tanks is often required by law. For pipelines, gauge pressure transmitters are used for pressure monitoring. They're normally connected to the pipeline via impulse lines because, due to the process conditions, there is no need for diaphragm seals. Measurements at wellheads need high pressure ranges. BB pressure transmitters can provide upper range limits up to 600 bar. In the chemical industry, level measurement in tanks is an important application. Sometimes the tanks are pressurized, for example reaction tanks, where it is then necessary to use a differential pressure transmitter for measurement, preferably with diaphragm seals for easy installation. Depending on the measured medium, an anti-stick coating on the seal diaphragm could be necessary. The process temperature of up to 120 degrees Celsius or 248 degrees Fahrenheit in these applications is no challenge for the diaphragm seals, where versions are available for use up to 375 degrees Celsius or 700 degrees Fahrenheit. The all-welded version for vacuum service provides high reliability for these applications. Where the tank, for example a storage tank, has a connection to atmosphere, the level measurement can be performed using a gauge pressure transmitter instead of a differential transmitter. Pressure at feed pumps for solvents must be monitored with pressure transmitters. Depending on the fluid, the material in contact with the medium may need to be made in part of highly corrosion-resistant material. To avoid dead space at the transmitter connection, front-bonded diaphragms or diaphragm seals will be used. Near a pump line, shocks very often occur. Pressure transmitters designed for high overload avoid damage to the sensor element. In pneumatic filling systems for silos for solids, gauge pressure transmitters are used for silo pressure monitoring. Monitoring of the filter status will be done by measuring the differential pressure between the inlet and outlet of the filter. For this application, diaphragm seals should be used having a diaphragm surface with a high resistance to abrasion, for example, made of Diaflex or coated with PTFE. As well as the oil and gas industry, the chemical industry uses pressure transmitters for pressure and interface level measurement at separators and level. The requirements for interface level measurement are the same. Low differential pressure ranges depending on the difference in density of the two measured media are necessary. The preferred connection method for differential pressure transmitters is the use of diaphragm seals for easy installation and to avoid problems which could be caused by impulse lines, for example, bubbles in the filling of these lines. Due to the measured media, the parts in contact with the medium need high corrosion resistance. At distillation columns, the top pressure must be measured. For this application, remote seals are used, often with a special filling liquid, to cope with the high temperature which can be used, up to 375 degrees Celsius or 700 degrees Fahrenheit. Distillation columns are an additional part of a chemical plant, where interface level measurement is carried out with differential transmitters having all welded remote seals for vacuum service. Process pressure and level measurement are the main applications in the pulp and paper industry, where pressure transmitters are used. The requirements differ depending on the process in which the instruments are used. For pulp production, front-bonded diaphragms are required. This can be achieved using diaphragm seals with an extension tube, with 1 inch or 1.5 inch connection and a flush diaphragm, or with special connections which can be integrated into a ball valve. At the digester, diaphragm seals are used with high corrosion resistance and good anti-abrasion properties, for example Diaflex or Super Duplex. At the pulper, diaphragm seals with a flushing ring are used to allow frequent cleaning of the diaphragm. The bleaching process requires front-bonded diaphragms as used in pulp production. In addition, there are diaphragm seals with an extension tube, with 1-inch or 1.5-inch connection with a flush diaphragm, or with special connections which can be integrated into a ball valve. At the drying section and in the boiler house, pressure and differential pressure of water and steam is measured. For these applications, standard transmitters with standard process connections are used. Multivariable transmitters are used for pressure and temperature compensated mass flow measurement of steam. What have you learned from this module? You have seen examples of pressure applications in the main industries. You now know the instrument's features which are necessary or helpful for those applications. You should be able to identify those kind of applications in industries which are different from the industries described, and be able to offer the instruments with the particular features there.